Okay, guys, so we're going to continue with integration. We're going to do 19D and 19E. And 19D is the integration of inverse trig function. So if you look at the formula book, you'll see the integral. The aim is integrating inverse trig functions. And you're going to see in the formula booklet 1 over a squared plus x squared dx equals 1 over a arctan of x over a plus c. And you'll also see the integral, you know what? Nah, we're also going to see the integral of 1 over the square root of a squared is x squared. You know what? Don't write this down. You're also going to see, I'm just going to write it over here. Don't write it down yet. You're also going to see the integral of 1 over the square root of a squared minus x squared dx equals the arc sine of x over a plus c. So we have to take care of these. Now, the formulas are right there. Let's just derive it and then go over some examples and then look for like exceptions or not breaking the rules, but let's just see how we deal with it. And that's, once again, it's interesting because we can't factor that, but it's important. So let's take a look at this. So what we're going to do, the technique for both of these is we're going to make trigonometric substitutions. So let's take a look at this first one. So we have the integral of 1 over a squared plus x squared dx. For this one, the way we're going to figure this out is we're going to let x equals a tan theta. You don't have to memorize this. You should know it. It'll help you a little bit if you get caught up. And you'll know it from the formula book and where the substitution came from. So if you see this and the answer is tan, you go, oh, the substitution was a tan theta. Fine. So, and we know what we're going to be doing. So I know I'm going to be substituting x in here, but I know I need to replace dx. So dx over d theta equals a secant squared theta, which means dx equals a secant theta squared theta d theta. Okay, let's substitute everything back in here. The integral of 1 over a squared plus a squared tan squared times a secant squared theta d theta. Now, we know what's going on down here. It's a squared 1 plus tan theta. We know that the secant theta goes out with the tan theta. We know that a goes out with a squared, right? And so we're left with the integral of 1 over a d theta. Okay, well there's nothing there. It's technically like a 1. So we know the answer is theta over a plus c. And we know that we want to come back into the world of x. So we go back up here. And we know that x over a equals tan theta. And so theta equals arctan of x, right? And so the final x over a, and so the final answer is 1 over a arctangent of x over a plus c. So that's where the formula comes from. So you might say, okay, no big deal, right? No big deal. So example 1, okay, I'm done with this pen, sorry. It's running out quickly. If you want to get me a Halloween present or a holiday present, get me black whiteboard markers. So let's use a new one. So if I use the example, let's do example 1. How about we do the integral of 1 over 4 plus x squared dx? You say, easy. I'm going to rewrite this as the integral of 1 over 2 squared plus x squared dx, and I can go right to the answer. The answer is 1 over 2 arctangent of x over 2 plus c. Nice. Now let's take it up a notch. Let's throw in a lot of different numbers. I'm going to keep the 1. How about we do the integral of, you know what, let's have some fun. How about 7 over 9 plus 25x squared dx? So you say, you know what, it kind of looks like the tangent. It kind of looks like it, but I got to do some manipulation. Well, maybe you want to take that 7 out. And maybe you want to rewrite this as 3 squared plus 5x squared dx. Now it's starting to a little bit closer like my arctan formula. Let me make one more substitution. I'm going to take that 5x out and replace it with u. I can do that, right? As long as if I'm going from x world to u world, I have to take dx to u world. No big deal. So I know that du over 5 equals dx. So I have, ready, pay attention. So we have 7 over 5, the integral of 1 over 3 squared plus u squared du, right? Bobbleheads. Now it looks more like what I want. 7 over 5 times 1 over 3 arctan of u over 3 plus c, but I don't want to be in u world, I want to be in x world. Make the final substitution. Final answer, 7 over 15 arctangent 5x over 3 plus c. It's not that difficult. You just have to keep in mind all the little things, but you have the formula here. You might say, Mr. Adler, could we, instead of x, if we did bx, could that be bx? Yeah, but you know what? You can think that through. Okay. Let's move on to the next formula in the back of the formula booklet. Let's drive it, and then we will work through some problems. So, we have this is the first one. The second formula you're going to see in the formula booklet is the integral from 1 over the square root of a squared minus x squared. And we know that from the formula booklet, it says it's the arcsine of x over a plus c. So we know the substitution we're going to make is x equals a sine theta. That's the substitution we're going to make. Okay. Well, I know that dx over d theta equals a cosine theta. Therefore, dx is equal to a cosine theta d theta. It's a little different because we bring this down, but we're not solving for d theta, we're solving for dx. And one time, you're not asked to do this, so this is just the derivation. Okay, let's put this together. So we have the integral of 1 over the square root of a squared minus a squared sine squared times a cosine theta d theta. Okay, well, let's see what's going on down here. I have radical a squared, radical 1 minus sine squared. And so you say, oh, you know what? That's 1 minus sine squared is cosine squared. The square root of cosine squared is cosine. That goes out with that. And the square root of a squared is a. That goes out with that. We're left with the integral of d theta. Right? Final answer, theta plus c. But I don't want to stay in the world of theta. I want to go back to x. So I know x over a equals sine theta. Theta equals arc sine of x over a. Therefore, the final answer is arc sine of x over a plus c. And that's the formula in the back of the book. Once again, you don't have to memorize it. It's there, but I want to show you how we got this. It's through these trig substitutions. Let's choose 2 examples. So, let's do a basic one, and then let's throw a lot of different numbers in and see how it affects the formula. Sorry, let me put the cap on the red again. So the next example we're going to do is, next page. The next example I want to look at is, how about the integral of 1 over the square root of 16 minus x squared? So example 3, I guess, right? Example 3, we have the integral of 1 over the square root of 16 minus x squared dx. Now, yeah, it's in this form. It's not x squared minus a squared. That's different. It is a squared minus x squared. Okay, and it's going to be very, very straightforward on the exam, and if it's there. And so, I'm going to rewrite this as the integral of 1 over the square root of 4 squared minus x squared dx. And I know it goes right into the formula, the final answer, arc sine of x over 4 plus c. That's straightforward. Let's throw in some numbers. How about, what? Let's take it up even more notches. Ready? You ready for this? Example 4. How about the integral of 1 over the square root of 10 minus x squared? Well, let's make it 9. So you're looking at this and you're like, well, it kind of looks like my sine form, my arc sine integral. It looks like that formula in the formula book, but these numbers are, I like 10, I don't love 10. That's okay. Let's still rewrite it as the integral of 1 over radical 10 squared plus 3x squared dx. Right? So we'll see what happens here. Once again, radical 10 times radical 10 is 10. It fits in our formula. Let's take it to 3x. So we're going to let u equal 3x. So that means du over 3 equals dx. And we're ready to go. So we have the integral of 1 over radical 10 squared plus, minus, I apologize, minus u squared du, and we have the 1/3 on the outside. Remember, the 3 was here. So the final answer is 1/3 arc sine u over radical 10 plus c. Final answer, 1/3 arc sine 3x over radical 10 plus c. That is the answer. That's it. Okay, let's move on. Now, the next thing we want to talk about are other methods. So you might see the integral. Here's example 5. The integral of 1 over 5 plus x minus 2 squared dx. 1 divided by 5 plus x minus 2 quantity squared. You might say, okay, that's still in the form of the tangent, so we know it's 1/5 arc tan x minus 2 over 5 plus c. And then you notice, wait a minute, it looks like someone completed the square, right? So the idea is, actually, that's not right. That's not right. What's the answer here? No, it's radical 5. The idea is, it looks like someone completed the square. So what you're going to get is, you're going to get something that, you're going to say, wait, this looks like someone completed the square. So that allows me to ask you the integral of 1 over a quadratic. And we saw that in the last year when we were graphing these things, we looked for the vertical asymptote, so we saw it was positive or negative. We knew what it looked like. Now I can ask you for the area under the curve. So, for example, I might say, number 6, what is the integral of 1 over x squared plus 2x, plus 10? Now, whenever you have something over a quadratic, when it looks like this, ask yourself, can I factor this? Can you factor this? You look at it and you go, no, I can't factor this, right? But I can complete the square. So can I factor this? If you can factor this, if you recall, we did partial fractions last year. We're going to go over it here. But if you can't factor it, you can complete the square. So we have the integral of 1 over x squared plus 2x plus 1 minus 1 plus 10. Right? So we have the integral of 1 over x plus 1 squared plus 9 dx, which is equal to 1 over 3 arctan of x plus 1 over 3 plus c. Nice. Now let's look, so that's basic. Now let's look at an example. Let's look at an example when you can factor, and let's review partial fractions. So we have the integral of 1 over x squared minus 4 dx. Now, you look at that and you're thinking maybe it's one of the formulas, but you realize it isn't one of the formulas. If you can factor your quadratic, factor it, and then we're going to break it up. So we're going to let's look at 1 over x squared minus 4. We can rewrite that as 1 over x plus 2 times x minus 2. Now it turns out, for this class, we're only going to be looking at quadratics that factor with no repeating roots. We can write this as a over x plus 2 plus b over x minus 2. I believe we did this last year. How do we deal with this? How do we break this up? Okay, well, first you recall factor your denominator and break it up into 2 parts. Next, you're going to multiply everything. Multiply everything by x squared minus 4. Okay. Now, we have 1 is equal to a times x minus 2 plus b times x plus 2. Right? Because I multiply, so the x squared minus 4 cancels out the x minus 2, leaving me with an x plus 2 on the numerator. It cancels out the x plus 2, leaving me with an x minus 2 up here, and then this whole thing gets knocked down. So we have 1 is equal to a plus b times x minus 2a plus 2b. Well, if you think about it, there's no x over here, which means that has to be 0, right? And this whole thing has to be 1. So we know that a equals negative b. Let's substitute it in there. We have 2 times negative b plus 2b equals 1. 4b equals 1. B equals 1/4. Well, now we can rewrite this. We can rewrite this whole thing as the integral. If b is 1/4, that means a is negative 1/4. Correct? That means we can rewrite this integral of 1 over x squared minus 4 as negative 1/4 over x plus 2 dx plus the integral of 1/4 over x minus 2 dx. Well, what do we... Sorry, my computer screen went down. Well, this is back to basics. Negative 1/4 ln of x plus 2 plus 1/4 ln of x minus 2 plus c. Who sees what I can manipulate this? It's actually 1/4 ln of x minus 2 over x plus 2 plus c. That's the partial composition. Let's try another example. Find the integral of 7 divided by x squared minus x minus 14. So we have the integral of 7 over x squared minus x minus 12 dx. Sorry, I think I said 14 before, I meant 12. Can you see that? Yeah, perfect. Okay, pause the video, try it on your own. Okay, we're back. We're back. Well, I'm going to pull out the 7. So I have one, you know what, I'm not pulling out the 7. So we have 7, so I know I have 7 over x minus 4 times x plus 3 is equal to a over x minus 4 plus b over x plus 3. I need to get rid of everything in my denominator, so I'm going to multiply everything by x squared minus x times 12. The x squared minus x minus 12 cancels this out, so I have 7. The x squared minus x minus 12 cancels out the x minus 4, leaving me with x plus 3. And the x squared minus x minus 12 cancels out my x plus 3, leaving me with x minus 4. Once again, 7 is equal to a plus b, x plus 3a minus 4b. I know that this is 0. I know that this is 7. A equals negative b. 3 times negative b minus 4b equals 7. B equals negative 1. A equals 1. Is that right? Yeah. Yep, because the 3 and the 4, yep. And so we have the integral. Is that right? Yep. Yep. Final answer, ln of x. Yeah, ln of x minus 4 minus ln of x plus 3 plus c. Sorry, and you can combine these. So you have ln of x minus 4 over ln of x plus 3 plus c. I feel like I made a mistake somewhere, but I'm not sure. I could be wrong. Maybe it's just a coincidence. Let's just try one more with, let's try one more. Now, in this class, in this class, we're only going to have a monomial over a quadratic. And as I said, the quadratic is never going to have repeating roots. So we can look at this problem. We can have the integral of 2x plus 5 over x squared minus 9 dx. You have a couple of methods of dealing with this. You have a couple of methods of dealing with. So the book actually says, it's kind of interesting. Yeah. No. Okay. So you can factor this. It's not a trig formula. It's not one of the integral formula of the book, so you're going to have to factor it. So we're going to rewrite this as the integral. Oh no, let's take this down. So we know it's 2x plus 5 over x plus 3 over x minus 3. And we know it's going to be a over x plus 3 plus b over x minus 3. You want to take a second on your own to do this? Pause it and see what happens. Okay, well, I'm going to multiply everything by x squared minus 9. Let's see what's left over. So we have 2x plus 5 is equal to a times x minus 3 plus b times x minus plus 3. So I have 2x plus 5 is equal to a plus b times x minus 3a plus 3b. And what's different now, it's not a big deal, but what's different now is that we know that a plus b equals 2, and negative 3a plus b equals 5. So I know that, and I do this really quickly, I know that a equals b equals 2 minus b. So therefore, I know that negative 3 times 2 minus b plus 3b is equal to 5. Negative 6 minus 3b plus negative b plus 3b equals 5, and therefore b is equal to 11 over 3, and that means that over 6, sorry, 11 over 6, that means that a is equal to 12 over 6 minus 11 over 6, which is 1 over 6, and then we get the final breakup, which is 1 over 6 divided by x plus 3 plus 11 over 6 over x minus 3 dx. Final answer, 1 over 6 ln of x plus 3 plus 11 over 6 ln of x minus 3 plus c. One last thing before we move on to the homework problems. Some of the books have, or you might see another structure. For example, they may see the integral of the square root of x squared minus 25 dx, and you might say, oh yeah, that's sine, right? And then, sorry about that. You say, yeah, that looks like sine, but the thing is, it's not. It's not. I'll give you a hint. Once again, this is further, and this is not in the course, but it's another. It's actually, yeah. This is not in the course, but if you see something like this, I'll give you a hint. You're going to let x equal 5 secant of u, and then you can see what happens. Once again, it's not in your homework. It's not showing up on the IB exam, but if you're interested. Okay, so for homework, you're going to do all of 19D, and you're going to do 19E. And so I looked at the first problem. So you're going to do 1 and 2. And then I looked at, I looked at, then this problem came up. It was the integral of 5x over 1, x squared plus 6. And they're like, yeah, break up the numerator. I'm like, how do we do this? And then I realized, no, they just said rewrite it like this. They said just rewrite it like this, and I was like, oh, what's going on here? This is simply like, just let u equal x squared. And that knocks out the 5x. And then over here, this is just what? This is just arctangent. And I realized, okay, that's all they're asking for in unit 19E. So you're going to do 1, 2, 4 through 8. Have fun. This is your homework for the whole week.